A new observatory has quietly begun sending back data so vast, so precise, and so revealing, that even scientists weren't fully prepared for what it would uncover. It's called the Euclid Space Telescope. And its first images are not just beautiful. They're unsettling. Unlike traditional telescopes that focus on individual galaxies or nebulae, Euclid was built for something far more ambitious. Launched by the European Space Agency in 2023 and positioned nearly 1.5 million kilometers from Earth at a gravitational balance point known as Lagrange Point L2, Euclid has one mission: to map the structure of the entire universe. Not just what we can see, but the invisible framework behind it. Its ultra-wide field of view allows it to capture enormous regions of the sky in a single observation, while still resolving individual galaxies in stunning detail. But here's where things get strange. Euclid doesn't just observe light. It detects the influence of something we cannot see at all: dark matter. Using a phenomenon called gravitational lensing, it measures tiny distortions in galaxy shapes. Distortions caused by massive, invisible structures bending space itself. In other words, Euclid is mapping the hidden skeleton of the cosmos. In its very first survey, Euclid captured hundreds of images covering a region of sky hundreds of times larger than the full moon. When stitched together, they revealed millions of galaxies. And that's just 1% of what it will eventually map. Let that sink in. What we're seeing right now is not the full picture. It's a fragment of something almost incomprehensibly large. One of the most striking observations comes from the Perseus cluster, located about 240 million light-years away. At first glance, it's a dense collection of galaxies. But when scientists looked closer, they found something unexpected: over 600 previously unknown dwarf galaxies hidden within it. These faint objects had gone completely unnoticed, until now. And they matter. Because dwarf galaxies are extremely sensitive to dark matter. Their shapes and positions act like tracers, revealing where this invisible mass is concentrated. The implication? Dark matter isn't just present. It's deeply woven into the structure of everything. As Euclid mapped larger regions, an even more unsettling pattern emerged. Galaxies are not scattered randomly across space. They are arranged along enormous filaments, cosmic threads stretching across hundreds of millions of light-years. Together, these threads form what scientists call the cosmic web. And Euclid makes it visible with unprecedented clarity. It doesn't look random. It looks organized. Almost like a network. A structure where galaxies flow along invisible pathways shaped almost entirely by dark matter. Even more unsettling is what lies between those filaments. Vast regions known as cosmic voids. These areas appear nearly empty, but Euclid shows they are not truly void. They are shaped and stretched by another invisible force: dark energy. This mysterious energy is believed to be driving the expansion of the universe, and possibly accelerating it. In Euclid's data, space itself doesn't just expand. It seems to be actively pushing matter apart. And here's where things become even more difficult to ignore. Some of the galaxies Euclid observes are over 10 billion light-years away. Meaning we see them as they existed when the universe was still young. By comparing distant galaxies with nearby ones, scientists can track how cosmic structure evolved over time. But early results suggest something unexpected. The universe may have organized itself faster than our models predicted. Galaxies clustered sooner. Dark matter formed structures earlier. Everything accelerated. This raises a serious question. Do we fully understand how the universe works? Or are we missing something fundamental? Because right now, the dominant components of the universe, dark matter and dark energy, remain completely unexplained. We can measure their effects. But we still don't know what they are. And perhaps the most unsettling realization is this. Everything we've discussed comes from just 1% of Euclid's mission. Over the next 6 years, it will map billions of galaxies in 3 dimensions. A dataset so massive that scientists will rely heavily on artificial intelligence just to interpret it. Meaning our understanding of the universe may soon depend on systems analyzing patterns too vast for human intuition. So what do these first images really tell us? Not that the universe is chaotic. Not that it's random. But that it is structured, interconnected, and governed by invisible forces we barely understand. Galaxies are not the architects. They are the visible result of something deeper. Something hidden. And that leads to an uncomfortable truth. Most of the universe is invisible. Most of what shapes reality cannot be directly observed. And everything we see, including our own galaxy, exists within a system built on physics we are only beginning to grasp. Euclid's images are breathtaking. But they're also honest. They reveal a universe that doesn't revolve around what we can see, or what makes us comfortable. And this is only the beginning. Because 99% of its map is still waiting to be revealed. When that happens, we may not just learn more about the universe. We may be forced to rethink the rules that define it.